Okay, so let me make sure that. Okay. So first of all, you have your toluene coming. So in process flow diagram, one thing you do is you number every stream. Okay? You number every stream so that when I'm having a discussion with you or my designer, I don't have to say, oh, the stream, the vapor stream that comes out of distillation column, what's the composition of that? I can just say, what's the composition of stream number 7, right? So I number every stream. So the inlet stream, let's say, is we number it by using a rhombus like that, okay? And you number it, so let's just say this is 1. And so naturally you would use the hydrogen as 2. Now there is no rule about which one is 1, which one is 2, really. You write them as what they are. And the important thing is after that, just like there is no rule for what my name is, once I choose a name for myself, I have to stick to it. All right, so this is stream 1, this is stream 2, this is toluene. So some of the equipment you will use here is actually quite straightforward. So you can imagine if you are bringing this toluene from somewhere, likely you don't have a pipe connecting you to some supplier of toluene who's going to just give it to toluene whatever rate you want, right? So what do you need there? Well, not a pump. Pump would mean that something is, you need a tank, right? You need a vessel. You need a vessel where you're going to put toluene, because toluene is likely not going to be pumped. So you have a vessel, and the vessel has typical shape. I'm trying to make sure that I use the correct shape, because so this is a horizontal vessel, and you call it V, vessel V, okay? And you number everything. So like this is stream 1, this is vessel, and this is 101. 101 because usually what happens, the plant is very, very big. So if you start numbering vessel as vessel 1, vessel 2, vessel 3, vessel 4 up to vessel 25 or 102, you will have no idea what is vessel 72, where is it located, you won't know, right? So what you do is, in this vessel number, the first 2 just designate the zone within a plant, the region, right? So like vessel 101 would basically be region 10, and then first vessel in that region, okay? All right, so that's vessel 101. Then this vessel, I'm essentially, like I said, I'm going to essentially draw the picture that's on the board. But if you want to take a course in design, this is exactly what you'll be doing. You'll be figuring out a diagram, and then of course finding out the volumes in each of these using some sort of simulators like Aztec. And then, so the liquid part basically comes from the bottom, and then usually you have to pump it. So you push it in a pump. You don't actually have to draw it. I can put it on. It's in the book. I can put it online. So drawing it is really not going to do anything. I don't even know if I really need to draw it on board completely, because the whole point is not to see. The whole point is to understand it's a picture that can be drawn from the plant. So anyway, next is a pump. The pump is drawn like this. Okay. And it's P101, A/P. So P for pump. 101 again is region 1, pump 1. A/B basically means that there's a backup. Okay? So there's a pump, you're using one, and then you have one in backup. And of course, pumps, usually you have backups. So you can pump this, and after pumping it, you can actually, this says you'll combine the gases along with it, and you'll send it to a heater. Because as I told you that this reaction takes place at very high temperature, so you send it to a heater. Okay? Which basically it's a heat exchanger. Heat exchanger, and you draw a heat exchanger like this. And this is called heat exchanger. All heat exchangers are denoted by 1 to an E101. Okay? And the utility stream here is high pressure steam. High pressure steam, HPS. Okay, so high pressure steam is what is used to heat it. And of course, it comes out at high temperature. It's still not fully, oh, we should also keep numbering the number of streams. So the way this is done is they call it this 3, they call this to be 2 after 101. They call it before 101 to be 2, this is 2. Okay. All right. Now this 4 actually goes into another heater.
Are you looking at the diagram on the computer?
Yeah.
You should just post it up so you don't have to.
No, because I think you just kind of see it more. If I just put it on board, you will not see why different part equipment is what. I will eventually show you the whole picture. But I want to kind of go through you like what different thing is doing. I think it's just different. Would you agree with that?
Yeah.
I mean, there's just a difference between seeing on board bit by bit coming together versus just seeing the whole thing, right? Because now you kind of have a better idea of why everything exists. So because it has to be, the only reason I'm looking at making sure it's the same thing is to make sure that the picture, I can never remember what picture, what equipment represents and what blocks all this. I don't want to give you the wrong information. So you now have to put it through another heater, and that's in this case happens to be a gas-fired heater. So it is drawn like this. Okay, so in this case, you get air coming in. There's also a heat exchanger. But in this case, you have air coming in, and you have gases coming in that are combustible. Basically, burn the gases, and then you have combustion products coming out. Okay, so it's another heat exchanger, except that in this case, of course, there's no direct contact between the two streams. This is obviously it's kind of like a shell heat exchanger, but it's kind of like a Q heat exchanger, but except in the outer phase you have these air and gas which is just burning. So now the temperature increases. You should put some number on it. We call it 6. And you see why. So this is 6. Okay. After this, what do you think will be the next step?
Draw.
Sorry?
Reactor.
Reactor, right? Yeah. And of course, you have to now bring in hydrogen into the reaction. So you bring hydrogen. Actually, you do add hydrogen at this stage itself. Actually, you add hydrogen at this stage prior to the high pressure steam. You could say, well, why do we do that versus adding it directly in? And you can see all of these options exist, right? You can add it here, you can add it directly there, or even directly into the reactor. Because as long as they're mixing, the question is, if you mix it here, is there going to be any reaction during this step, and will that reaction cause any problems, right? So those are the kind of issues that depend on the material of construction. But in principle, yeah, you can add hydrogen at any step. You can also, in fact, add it at different steps. But anyway, hydrogen is added. Number 6 basically goes into a reactor, which is basically simply a block. Okay, so that's your reactor. And of course, what will come out of the reactor? There will be at least 2 streams, right? One will be the bottom,
Is it
and one
5?
will be the top. Sorry?
Is it 5?
Reactor, no, so the recycle stream is, they're numbering it 5. I just want to make sure the numbers are consistent here. So you have one stream here, which now goes to a cooling water because this is a reaction product. This is going to be very hot. So it goes to another heat exchanger. This is cooling water. What comes out is basically cooled. Now, if you think about it, at various places, you probably need to put more pumps because right now you have only one pump. The question is this pump enough to really take it all the way through? You probably need a pump here or a compressor here. If you choose another one. And also, this is a part of the, so this recycle stream, a part of it, of course, is going to be an unreacted component. It will be gas phase. You have to basically bring it back, and you recycle it at some stage. And again, you can recycle it in principle at any of the stages, or you can have multiple, recycle here, or potentially recycle here. All right, and after that, you can kind of, so hopefully you get an idea by now. And of course, what's the next step? So now you have a product. And as we discussed, now you're going to have a separation stage, right? So you're going to have a distillation column. So distillation column, you have a stream, you have condenser, you have recycle, you have reboiler, and then you can take some of the product out, right? And this would be your benzene, and then of course all these light gases can combine together if you want. Light gases from here. Okay, so this is not actually exactly complete. I'll upload this, and you can see the important. But the important thing is, what are the important things? The important things are now we're actually putting every equipment in, and what type of equipment it is. Okay, it's a heat exchanger. We're putting heat exchanger. It's just a vessel. So really now you have a better idea of what every equipment is. We're putting in numbers for every streams, right? Also, we're indicating all the utilities, right? And then, of course, you have to put in a few more details, like all the mass balances. And once you put in all the mass balances, that's essentially a process code item. Yeah.
For equipment, like in most situations, the process would we consider like flame arresters and things like that?
What's that?
Flame arresters.
You would probably not put. The question is, what about flame arresters and some more peripheral equipment? You'd probably not put that in a PFD. You probably look at it as a piping and instrumentation diagram like PNID. You probably save that to the next level, yeah. Now, has anybody seen a PFD? Those of you who done internship, you must have seen these big diagrams, right? They're usually in blue. Then these big papers that typically get folded and they get given to you when you do internship. So that's what a PFD is. Okay, so usually there are these big sheets. And yeah, all right, so we'll continue.